Hey everybody, so the law of combining volumes is what we're going to cover in today's lesson, and the underlying concept with this law is that you need to understand that all gases, regardless of what we think their size is, and you can see that these sizes look like they're kind of a little bit different, all gas molecules are very teeny tiny, and they're all about 20 to 30 times apart from each other. So what this means is that if I have 1 mole of a particular gas, it's going to occupy a certain volume. And the thing about gases is that it doesn't matter what gas it is, it will all occupy the same space or volume if you have 1 mole of it. So, for example, if I have 1 mole of nitrogen, it's going to occupy volume X. And if I have 1 mole of hydrogen, it's going to also occupy volume X. Not 2x, not 1/2 x, not a different amount of volume. It's going to be exactly the same as the nitrogen because I've got the same number of molecules present. And if I have the same number of molecules present for ammonia, then it's also going to occupy volume X. And so if you take a look at this balanced reaction right here, which is the formation of ammonia, you can see that these 3 gases are present in this chemical reaction. And what we know about balanced chemical reactions is that this is a coefficient of 1, which just essentially means that if I have 1 mole of nitrogen, that's going to need to require, or is going to require to react with 3 moles of hydrogen. And when those amounts react, they'll react in the correct proportions to give us 2 moles of ammonia. And so this makes sense. We've covered this in our previous lessons. But now, because gases also follow this same concept where 1 mole of this is going to occupy the same volume, whether it's this gas, or this gas, I can also now use units of volume to predict what the amounts are going to be that are going to be produced in units of liters or milliliters or whatever. So, for example, if I had 1 liter of nitrogen, again, that's going to have a certain amount of molecules in it. And if I have 3 liters of hydrogen, that's going to occupy, or that's going to have 3 times the amount of molecules in that container. And that's all I care about, is that this ratio is reacting at a 1:3 ratio. And the volumes contain or uphold that ratio. And so 1 liter of this is going to react with 3 liters of hydrogen to make 2 liters of ammonia. And I can use this for any unit of volume and any number. So if I had, for example, 75 milliliters of hydrogen, how many milliliters of nitrogen would that take to react with it completely to produce how many milliliters of ammonia? So you can pause the video right here, try this one out on a piece of paper, and then start the video again. Okay, so hopefully you got your answer ready to go. Nitrogen here is going to be 25 milliliters. And the reason why is because you can see that this coefficient here of 3 to 1 means that I need to have 3 times as much volume of hydrogen as I do nitrogen in order for that to react completely. And so 25 is 3 times less than 75, and so that works out and fits that ratio quite nicely. And then the amount of ammonia that's going to be produced, well, again, you can see this is just a 1 and ammonia is a 2, so that should be double the amount of nitrogen that I have. And so if I've got 25 milliliters here, I should have 50 milliliters there. And if you can do that, you guys understand the law of combining volumes just fine. Hopefully this was clear, and we'll see you guys in the next video.